My name is Oscar, and in this video I'll explain the fundamentals of objects and key value pairs in a software program. The idea of a key value pair is very similar to that of a variable. We have names and values to our variables. Conceptualized a little differently, you have a name that describes something like number of trees. We're going to call that the key. Think of this key as something that can unlock the value. Let's say 4, number of trees is 4. We now pair those two things together. When you have lots of keys, it's important to make sure that they're paired up with some value, and that's kind of the difference between a variable. You can declare a variable, but a key value pair needs to have both together. So a lot like variables, key value pairs can be virtually anything. So for example, color of tree might be brown. Height of tree in meters might be 6. Number of leaves on tree might be 143. Width of the tree trunk in centimeters, 100. We can use any number of key value pairs to describe what's called this object, which we know to be a tree. And an object is particularly abstract since it could be so many things, but they basically let us take our variables and key value pairs and organize them in order to understand what the program is doing. For example, are we talking about one tree in someone's yard, or is there an entire forest of trees spanning hundreds of acres? To make this jump in comprehension, we do want to try and draw this distinction between key value pairs and variables. So using our analogy of variables as boxes, we have 5 different key value pairs and 5 variable boxes that each store information about those 5 different characteristics of the tree. We can group all our variables together into a single variable called tree, for example. Sometimes in code you'll see this denominated as an uppercase, capital T for tree, which constitutes an object, and it's a little bit different than regular old variables. So again, we use language skills and capitalization to draw these distinctions in the concepts that we're talking about. So now imagine a large chest with conveniently labeled internal compartments. Let's say each of these compartments contain one of the 5 variable boxes that we were handling individually before. So an object, in this example our chest, is useful for organizing variables in the form of key value pairs all grouped together, and we can carry around the chest throughout our program for later use. There's actually no limit to the number of boxes you can place within the chest. So your object can be as complicated and have as many key value pairs as you can imagine to help describe something in your program. We can define another object, for example, called forest, and it can contain 100 different trees, all with different values for color, height, number of leaves. We can keep going and define an even bigger object called North America that contains thousands of different forests that each contain different trees, and so on. So we can place our boxes within chests within bigger chests, and this allows for a lot of dynamic flexibility in what we're defining for our program. So this last idea can be overwhelming. With increasing levels of scale, there's no end to this. Programs that are able to keep track of all of these objects within objects need to contain strong iterative constructs to be able to get through all these trees and forests without getting totally lost thinking about how many variables there are. The next section will talk more about how iterative constructs can help make nested objects within objects a lot more manageable.